I'd like to thank the organizers for the invitation to the ALMER meeting and the ACCR symposium. And today I'm going to talk about the environment, routes of exposures and vulnerabilities, endocrine disrupting chemicals, personal habits, air pollution related to ovarian function, and approaches to mitigating effects. So what do we mean by the environment? It comes from the French word to surround, and environmental components affecting health include chemical toxicants, climate change, heat and air pollution, and these cross borders by trade, wind, food, and water, and they affect everyone, and especially the most vulnerable, women, pregnant women, and children. Reproductive health can be affected directly or indirectly through non-communicable diseases that are attributable to these environmental components. Now, what is the magnitude of the problem? Well, there's the global chemical production. You can see here the increase in global chemical production from 2000 to 2050, a fourfold increase above current levels. And this is on top of the 25-fold increase from World War II to 1995. As of 2020, there are over 350,000 chemicals and mixtures registered, mostly unregulated, and there are wide differences across regions and countries. With regard to global warming, we're all aware of the temperature changes that have occurred in the last 50 years, and these contribute to worsening air pollution because they extend the ozone season, causing droughts and storms and fires and smoke. And the sources of air pollution include burning fossil fuels, coal-fired power plants, gasoline-powered cars, diesel trucks, and the emissions include particulate matter, volatile organic carbons, nitrogen oxides, and carbon dioxide. So there are some periods of vulnerability to disruption by environmental factors. These include preconception, prenatally, and postnatally. And we should remember that prenatally exposes not only the mother and the fetus, but also the reproductive cells in the fetus, affecting the generation that is not directly exposed. So transgenerational transmission of insult. So how do we arrive at scientific evidence linking environmental toxicants and reproductive dysfunction? For human data, we rely on epidemiologic observational cohort studies. With regard to understanding mechanisms, we do derive these from animal studies and in vitro models, and also wildlife observations are important. And these data are often reviewed in systematic reviews and meta-analyses. Now, with regard to environmental reproductive toxicants, these include a group of chemicals called endocrine disrupting chemicals, or EDCs. These are chemicals or mixtures that interfere with any aspect of hormone action at any time of development and or during the life course. These include environmental contaminants that are persistent, such as dioxin and PCBs and tributyl tin. They are present in as plasticizers like phthalates in children's toys and in cosmetics, bisphenol A, which is in paper receipts and also plastic bottles, pesticides, preservatives, and hand sanitizers. In addition, air pollutants can affect reproductive health, including black carbon and particulate matter and heavy metals. The routes of exposure can be through drinking water, living near or working in agricultural areas, from personal care products, food containers, paper receipts, electronic waste, household dust, and fillings in furniture, as well as air pollution, both outdoor air pollution and indoor air pollution. Now, endocrine disrupting chemicals disrupt reproductive potential on a variety of levels, and today I'm going to focus specifically on ovarian function. The early findings from Pat Hunt's group showed that maternal bisphenol A exposure disrupts early meiotic events in the fetal ovary. Fetal BPA exposure increases oocyte loss, and in addition, in the maternal side, abnormal eggs and embryos were found, and it was found that this was transgenerational. EDCs adversely affect prenatal and neonatal ovarian development in animals and humans. This includes decreased ovarian weight and follicle growth and increased atresia. And some of the bad actors are organophosphate insecticides that activate primordial follicles, increase apoptosis, and epigenetic alterations in ovarian genes. TCDD increases follicle atresia and inhibits growth and primordial follicle loss in the F3 generation. DES, or diethylstilbestrol, reduces the primordial follicle pool and increases atresia, and BPA impairs meiotic progression of cultured fetal human oocytes, increases recombination, and induces epigenetic changes and chromosome congression failure, as you'll see shortly. So all of these these effects are experienced with in utero exposures. Looking at meiotic progression and recombination, these are affected by BPA, and this was a study done a few years ago where human fetal ovarian follicles were incubated with BPA at several concentrations or estradiol. And that's because BPA structurally is similar to E2 and acts at the estrogen receptor. The main findings were decreased egg oocyte survival and increased MLHI loci, a crossover marker. So the conclusion was that BPA can affect key events in meiotic phase and oocyte survival in the human fetal ovary. But EDCs also adversely affect the postnatal ovary, inhibiting follicle growth, increasing atresia, apoptosis, reduced egg quality. And these data are from mice, rats, hamsters, lamb, sheep, and epidemiologic data in humans or in vitro studies. We see organophosphate insecticides again have effects on the postnatal ovary, and phthalates induce apoptosis and accelerated primordial follicle recruitment, inhibit follicle growth, and augment apoptosis of granulosa cells. In addition, dioxin increases inflammatory genes in granulosa cells, and BPA decreases all follicle types and increased atresia in adults. Finally, chlorinated biphenyls in human follicular fluid are associated with low fertilization rates and lower high-quality embryos. Looking at BPA and human egg maturation in vitro, this shows a decrease in the percentage of eggs that progress to M2. There was an increase in the percent of degenerated oocytes with increasing BPA exposure, and an increase in the percent of eggs that had undergone spontaneous activation. Among the M2 oocytes, as the BPA dose increased, there were decreased bipolar spindles and decreased aligned chromosomes. So putting this all together, we see that endocrine disrupting chemicals can disrupt prenatal and postnatal ovarian development, egg quality, steroidogenesis, and menopausal timing. And this is true at every step of the ovarian cycle, as well as every step of the steroidogenic pathway. Now, IVF and fertility cohorts have been given even more insights into associations between environmental toxicants and reproductive potential and outcomes. And there are several recent cohorts, the EARTH study, the SMART study, and the LIFE study. And we know that with IVF patients, there are many fluids and cells that we have access to where these chemicals can be measured. Indeed, a recent systematic review of prospective cohort studies showed associations between specific endocrine disrupting chemical exposures, reproductive potential, and outcomes of women undergoing IVF. You can see here decreased serum estrogen levels with higher levels of BPA, PCBs, decreased serum AMH levels. Parabens and phthalates were associated with low antral follicle count and poor egg quality. Also, we see lower fertilization rates, implantation rates, poor embryo quality, and low clinical pregnancy and live birth rates associated with these various endocrine disrupting chemicals. And cause and effect is usually demonstrated at the level of the animal studies, as mentioned before. And with regard to personal habits, environmental tobacco smoke certainly affects reproductive health. It decreases fecundity, ovarian reserve, success rates in IVF, and accelerates menopause between 1 to 4 years. And the mechanism is thought to be due through the aryl hydrocarbon receptor mediated apoptosis of eggs, which is induced by cotinine, which is a component of tobacco smoke. And there's also data to support increased miscarriage rates, low birth weight, preterm birth, and transgenerational effects. The mechanisms underlying endocrine disrupting chemical effects are mainly through estrogen receptors, if these are estrogen mimetics, or through the aryl hydrocarbon receptor, such as through cotinine, but also through other receptors, thyroid receptor and androgen receptor. And in addition, what happens here is downstream effects to alter gene and protein expression and cellular function. And some of these are mediated through epigenetic mechanisms. Now, what about climate change and pollution? This is a study from the Earth Study that showed that close residential proximity to major roadways is significantly associated with lower probability of implantation rates and live birth rates after IVF. So women living more than 400 meters from major roadways had higher live birth rate compared to those living closer to the major roadway, less than 50 meters. There is a whole literature of effects of pollutants on ovarian functions, mostly animal studies, but also human observational studies, with the bottom line, a decreased number of primordial follicles with exposure to diesel fuel, and benzene associated with irregular menses, and occupational exposures to other organic solvents resulting in oligomenorrhea. And the mechanisms here are very similar to those of the endocrine disruptors. They induce reactive oxygen species, formation of DNA adducts, epigenetic modifications, and disrupt normal gene and protein expression, and therefore cellular and organ function. So what can we do to change course? Policy certainly helps, policy changes, education, and also one by one. So looking at what we can do as healthcare providers and what our patients can do. Eating fresh food and minimizing processed and canned foods that contain plastic liners. Washing all fruits and vegetables and hands thoroughly and eating organic foods if possible to minimize pesticide exposures. Trimming fat from meat and skin, from fish, to minimize exposure to fat-soluble chemicals. Store food in glass or stainless steel containers. Avoid certain plastics, number 3, 6, and 7, and use BPA baby formula bottles and toys. And avoid heating or microwaving food in plastic containers or plastic bottles, and avoiding nonstick pans. Now, around the house, simple things. Removing shoes before entering, cleaning floors with a wet mop, avoiding dry cloths and sweeping because of the chemicals and dust. Use alternative household products such as ammonia, soap, and vinegar, baking soda, and fresh air. No home pesticides, but rather use insect baits, not sprays. Avoid toxic flame retardants. minimize burning wood and trash, and asking for volatile, organic compound-free and water-based materials for home building and improvements. And then finally, practical solutions for personal habits and personal products. No smoking, even secondhand, phthalate-free makeup and other personal care products, using fragrant-free rather than unscented, avoiding hand sanitizers when possible, avoiding lead, especially in makeup, and then air pollution, checking local air quality if the data are available, avoiding high particulate matter air pollution, staying inside if necessary, and exercising away from high traffic areas. Wearing a mask outdoor if in high particulate matter conditions, and a home purifier, and avoid idling cars and other vehicles. So together, we can protect our reproductive health now and for all generations. And through FIGO and through IFFS, we are putting together materials for patients as well as physicians. So I would like to thank you for your attention, and I'd like to invite you all to the IFFS 2022 World Congress in Athens in April next year. Thank you.